What's up, YouTube? It's John David Roth, presenting on projectile motion, kinematics, and energy. So, introduction is the purpose of this lab is to model projectile motion using two methods, kinematics and energy conservation. So, we're going to compare the predictions to each other. Going into this, we should know that the energy method and kinematic method produce identical trajectories, confirming that both approaches correctly describe the ideal projectile motion. Experiment setup. So we used a quarter launched at an angle and tracked its motion using a tracking software. We built two computational models in VP Python. Both models were compared against each other to evaluate consistency between two physics approaches, and no drag was used in either model. These are the physics principles that I used. So the kinematic method, we had Newton's second law, so F net equals ma, the velocity update formula, the position update formula. And for the energy method, we use the conservation of mechanical energy, kinematic, or the kinetic energy, potential energy, and we use the equation to find the speed at any height. Systems and surroundings. So the system was the quarter, surroundings being Earth and the air. But in this model, we did not use any drag, so ignore that. And it's important to know that as energy flows, so as the energy rises, or as the quarter rises, kinetic energy converts to potential energy. As the quarter falls, potential energy converts back to kinetic energy. So the total mechanical energy remains constant throughout. This is our computational model for the kinematic approach. So we can assume that only gravity acts on the ball. There's no energy, no air resistance, and no energy lost. It's a symmetric parabolic trajectory. Yeah, so for the method, at each time step, we calculated the F net update velocity, and using the momentum principle, we did the update position. This is the energy computational model. So no drag, total mechanical energy. So E equals kinetic energy plus potential energy. It's the same graph. So yeah. This is the code for the kinematic loop. It calculates gravitational force, uses the update position formula and the update velocity formula. This is the code for the energy loop. It calculates the potential energy, the kinetic energy. It derives the speed and then updates the direction using gravity and then plots the information. Similarities and differences. So both use the same initial conditions. They both satisfy Newton's second law. The differences is the kinematic method updates velocity using F equals ma directly. Sources of error. So there could be something wrong with the tracking software, like not using exactly the center of position for the quarter. Yeah, that's about it. Conclusion. So we could see that it was going to be the same graph, kind of calculates it, but different steps, different kind of physics going on behind the scenes. So yeah, that's my lab submission.